we are gonna do another question, which is which of the following list only um, two vectors quantity two vector quantities two vector quantities. So the options are mass, option E, mass, energy, and work. The second one is momentum, work, work, um, work, and speed. Damn, speed. I have forgotten to write. And third one is weight, force, and acceleration. And the fourth one is momentum, energy, and displacement. So I know the answer, it is momentum. So the obvious question next is why is it momentum? So to understand momentum, let's copy this and let's put it over here. So what I'm gonna do, I'm gonna list what they are on the top of them. So mass is a scalar, energy is a scalar, work is a scalar. We will talk about what they are very shortly, pretty quick. Momentum is a um, vector, work is a scalar, and speed is a scalar. So there are three scalar in A, two scalars, and one vector in B. And the third one, weight is a vector, force is a vector, acceleration is a vector. And so there are three vectors. So obviously this is the answer, but still, let's see. Momentum is a vector, energy is scalar, and displacement is a vector. So there are one scalar and two vectors. So that's the thing that we needed. So two vectors is the thing that we needed. Hence, that's gonna be the answer. So I told you why, what they are, but let's talk about them individually. So scalars are the things that do not have a direction. So let's just think if they have a direction or not, and that will make us much more easier. I will also show formulas if they have some. So mass, I'll write it with a different color, so this is not that necessary to write. So mass, it's represented by m, and it's the amount of thing. So it is the amount of thing that something has. So mass talks about how much, the amount of things that it has. And after this, mass. So mass is a scalar, since when you're talking about amount of things, you don't need the direction of the thing, right? So when you have amount of things, you don't need direction. The next one is energy. So the energy is represented by E generally, and energy is the how do I say it? Let me think. Energy is the capacity of doing work. So it's like how much work can something do. So when you're talking about energy, you're not talking about the direction, you're talking about how much something you can do. But now, also let's write the mass is amount of substance, whereas energy is capacity of doing work, right? So now we are going to talk about work. So work is generally represented by W, and why is work a scalar? Actually, I want to change this mass from amount of substance to rather um, amount of matter. So amount of matter, because matter will be a much more suitable word. And work, the formula of work that you should have known is vector force into displacement. So when I look at this, my question is vector, 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 and the answer is no. Even though this is vector, vector, this is not vector. This is not vector because there is a dot product. You will, I don't know, have I taught this? Anyway, this will come up, okay? I'm gonna teach you what is dot product later. I don't know, I have already taught it or not. But anyway, what is work? So work is just for using force to move something a specific distance, and it's the energy when you use that force. So it's kind of the energy. So it's the energy that you use when you move something by a force. So you don't really need the direction of the force, right? And you really don't need the direction of the movement. So since you could have moved anywhere, but it would still be the same work if if you're moving the same distance, same displacement with the same force, right? So I think I did not explain that pretty well, but I'm not gonna try it once more. So next is momentum. So momentum is generally represented by P. Why P? Not really sure. Let me check. Let me Google it and check it. So I actually looked it up, and it actually comes from the Latin word petri or peteri, something like that. So first of all, let's write what this is. The formula that you will commonly find is P times, so mass times velocity. Since velocity is a vector and you're multiplying a vector by a scalar, it will still give a vector. So we will talk about this later, or I have already talked about this, one of the two options. And um, momentum, if you have to define it, it's just the quantity of motion. It's the quantity of motion. So it just tells you how much does something move. So just imagine if there is a small ball and it's moving with a high velocity, and a big ball moving with a slow velocity, they might have the same momentum, which means might have the same quantity of motion. But the distance traveled by the small ball is going to be much greater. But it's traveling that distance because it is small, right? And it has less mass, right? Um, and when I'm talking about small and big, I'm talking about mass, not the size. Since both the things can have the same size but different sizes, same mass but different sizes. Also, let's write the Latin thing, because why not? I like Latin. Let's use another color. Let's use this green. So it comes from Latin. I don't know how to say. And the word is peteri or something like that. And it means to go forward, or to seek. So pretty much like it's like talking about motion. That's why um, the symbol is P. I actually didn't know this. Like, this is new for me as well. The next one that we're gonna talk about work. We have already talked about work. Speed. We have not talked about speed. So speed is generally represented by V, only V. Momentum is generally represented by this. I forgot to make the vector sign. Sorry. Um, and the most common formula that you will find of speed is basically distance over, so distance over time, and that's the definition. So it's the rate of um, how to say it. I think it would be distance traveled per unit time. So if I say the speed is 10 meter per second, it would mean that every second I would have traveled 10 meter, which is an insane distance, I would think. I think 10 meters is big, right? Not sure, not, I have no idea. I'm just saying stuff. Okay, the next one that we have is weight. So weight, which is generally represented by W as well. The formula is weight equals mg. So that's the most common formula that you will find, where m is the mass, g is the acceleration due to gravity. So where is the vector sign? So gravity is a vector, the acceleration due to gravity is the vector, which means it's multiplying by the scalar, which leads to a vector. So this is going to be a vector. So weight is basically the gravitational force acting on a body. Acting on a body. So it's basically a force acting on you. So that's weight. Another one that we have is force. Force is generally represented by vector F, and the most common formula that you will find, and which is mass times acceleration. As you can see, gravity is acceleration. Acceleration due to gravity is acceleration. So these two formula are basically the same. It's just that weight is the gravitational force acting on a body, whereas force is the push or pull that you feel. So it's push or pull. Pull. Okay. Let's see what else we have. We have acceleration. I don't think we talked about that. So acceleration is generally represented by vector a, and the formula of acceleration is velocity per time. And this is not speed, this is velocity. So there's a vector arrow, it means it's a velocity, and it is basically velocity rate of how can I tell you, I think rate of change of rate of change of velocity. I think that would be a pretty good definition for acceleration. And after that we have momentum. I think we did momentum. Yep, we did momentum. After that we have energy. We did energy. And finally we have displacement. Displacement. I think it is represented by D normally, but I think I have also seen S. So let me just, so yeah, even distance, oh sorry, speed is not here. I wrote D. It's supposed to be S, since distance is represented by S. Displacement will be represented by S with a vector sign. So, and the most common formula, I don't think there's a like formula. I don't think there is a formula, right? The displacement is basically the final minus initial. So these are the position vectors. Position vectors. So have we talked about that? I don't know. But okay, let's talk about why is this S. Because I also did not know. I just looked it up. So it's also from Latin. So whenever we see weird symbols, we just have to assume that it's from Latin. So it's from Spartium. Okay, wait. Let me listen to the Google once again and listen how it's. Okay. It's actually called spatium, not Spartium. It's called spatium. Spatium. Okay, spatium. So spatium, and it means space or distance. So it means space or distance. So makes sense to call this displacement, right? And this is called pateri or something like that. I will probably forget about them after the video ends, but it's cool that you get to know this at least. So displacement is the shortest distance, or you can say a straight line distance as well. Shortest straight line distance. What I mean to say is there are 2 points, let's say this and that, and there are multiple ways to go from here to there. Any way that you take, and the way that you took will be the distance, whereas the shortest straight line, so this line is going to be the displacement. I will teach you about that in someday, I hope. So yeah, that's it for today's video. I think I talked about all of the topics. We'll obviously go in depth in all of these topics when we get to the topic itself. But I think this is it for today's video. In the next video we are gonna do another question. So till then, bye bye.